All right. Looks like we're live, or at least I think I'm live. I see Martin from Florida's here. Awesome. If you can hear and see me, please throw something in the chat. We're still a tiny bit early, just a few seconds before my clock just hit 8 o'clock. So we're right there. Hopefully, anyone? Okay. Douglas is here. Please let me know if you guys can see and hear me. Excellent. Awesome. We're doing well. I see Charles is here. Douglas is here. Larry's here. Hopefully Larry's walking late, around these days. Troy's here. Thanks for the kind words about the article in Fine Woodworking. Tim. Awesome. Kevin. Skip's here. Dexter. Awesome. Well, thanks. I was hoping I was looking good. Dave Redland's here. Brian is here. Jimmy's here. Perfect. All right. So we're going to get going. So welcome to No BS Woodworking Tuesday Tips. Tonight we're going to do some fascinating fasteners. We're going to talk a little bit about nails, screws, wooden pegs, all of that kind of stuff, where you might use them, where you might find them, the differences between the stuff that was made 200 years ago, 250 years ago, and the stuff that's made today. Hopefully we can get through this pretty easily and quickly. I want to make sure that I'm covering some kind of questions there. It's hard for you guys to see yet because I'm still on the wide shot, but I do have some bolts here too, and I wanted to show you those to kind of illustrate some of the manufacturing differences that have taken place. Oh, Frank's here too. Awesome. Larry's walking, but limpy. John's here, and both Johns are here. Awesome. That's cool. We're getting there. So again, the idea is, a lot of people think period furniture means, which is what I've done most of my career, means that you're cutting stuff like mortise and tenon joints and dovetails, and there's no metal in these pieces at all. There's no fasteners of any kind other than the hand cut or, in modern day, machine cut versions of these joints. And that's just not so. They used nails as clamps. They used screws sparingly. They used wooden pegs quite often. And again, on my bench here, I've got laid out various period examples and some new samples of those same things. So I'm also kind of hoping that Mike Michelli shows up, because all the way on this side over here, you'll see it in a minute, I've got something that might actually interest him. So I'm going to switch cameras here. We're going to hope I nail the presentation. Okay. Clinching. I'm not sure what you mean by that, Skip, but I'm not going to cover clinching in this. This is more a discussion about what they are, how they were made, how they were used, than it is how to actually drive in a screw or a nail or something like that. So again, on the bench here, you've got a nice little collection of a variety of things. Um, these are some 18th century hand forged bed bolts, and this is where I really wanted to start because I'm going to start actually with the screws because they're probably the thing they used the least in the 18th century. And what you can see, if I'm going to try and I'm going to move my little pile out of the way here so that I can kind of put things in perspective, get things where you can actually see them. And then I'm going to zoom in a little bit so that it's even easier. So again, I'm starting with bolts, which is not exactly something they used regularly. Oh, cool. I'll zoom in just a tiny bit so that you can see what I'm talking about when it comes to how these things are made. So again, 2-period bed bolts. These were used to attach the bed post to the rails. You can see they've got these square kind of nuts here. So what they would have done is this is just a piece of bar stock that they drilled the hole into it and then tapped the hole. And if you look at the threads on this, you can see they're kind of deep. They're all hand cut threads. Now they were using a die. They weren't just sitting with a file and randomly filing these things. They actually used a die to create this. So it's hard to see in the video, I'm sure, but the upper part of this shank, you can clearly see it's faceted from when they forged it on the anvil. And then the head is just basically a big mushroom cap that they sawed a saw curve in there, and they would have tightened it with a screwdriver. And again, here's another one. Again, nice deep threads on there. The diameter of this changes a little bit at this point. It's a little wonky because it's hand forged. Same, the other one's a little more uniform. And I'm not sure it shows up on camera, but you can kind of see where they were threading this thing, and up here where they stopped running the die down there, you can see where it sort of ends, and it's very abrupt, and there's a nice big burr that's all burnished over after a couple of 100 years. But there's a burr all the way along that bottommost thread, which is kind of cool. And the idea here is, once again, they would usually capture this nut inside the bed rail, and the bolt would come through the bed post and into the bed rail and then tighten on. So if I look at the modern one, first thing you'll see is it's got a big cap on the end with instead of a slot for a screwdriver, it's got sort of a squarish head so you can use a bed wrench on it. The shank of the bolt is quite uniform and smooth, and then it's clearly pretty heavily machined from that point on. This is all done on a screw machine. These things are just cranked out by the hundreds or the thousands, whatever. And then they just made a square bolt. This was actually just a bunch of cast material, and then they sheared it off, it looks like. So these thread in exactly the same way. There's really not a whole lot of difference in how it functions. This was actually one of the more expensive parts of having a bed made, because this mechanism required specialized tooling. You had to buy a tap and a die. You had to have some kind of more specialized training than just being able to stand in front of an anvil and hammer out a piece of round stock. So it's kind of cool. But it's also, they're kind of rare, and originally they were pretty expensive to buy. And that's exactly why I'm going to move on to the screw end of things here. If I start to look at the screws, and hopefully this is tight enough on the camera that you'll actually be able to see. If not, I can zoom in pretty quickly. I'm looking at the camera here. There we go. Now you guys can see. Kevin says, periodically when I'm advancing a square nail, they will rotate to the point that I need to hold the head with needle nose to keep it straight and avoid splitting. What's going on? Okay, we'll get to that. I won't ignore it completely, just mostly. I'm trying to get this kind of centered on the camera here. These two screws here, this big screw, and most of these in the back here are varying stages of 18th and early 19th century screws. The earliest ones being these really tiny short ones, and the one that's rather corroded and painted up. I think this might have been in a house that burned down, by the looks of it. There's an awful lot. I have a whole bunch of these screws, and they all have all of this weird oxidation on them. But these small ones, if you can, I'm going to try and set it down and pull it back into the center of the camera there. I mean, you can actually see just how deep those threads are. They're all hand cut, and they do stop up at the top, no burrs. The cool thing about them is that if I get these set up right, you should be able to see that the slots are slightly that they're slightly off center. So they were hand sawn afterwards. So again, here's another. This is like early 19th century, so 1800s or so, and it's still there. When we look at those threads, the threads are a little bit more. They're a little finer, a little bit more evenly chased around there, but then the slot for the screw certainly is sawn off center. Same thing. It's going to be really hard to see the slot on that very big screw, but it's the same kind of a thing. It's just slightly off center. If I compare that to a modern machine-made, mass-produced screw, these things the threads aren't as deep. No, I mean, nowhere near as deep as the ones on the period hand cut one. The slot in the head is absolutely perfect. The edge of the head isn't nice and sharp. It's rounded over. Where you would find these things on period pieces, clearly, I mean, an awful lot of hinges were applied, put on with screws, mostly hardware type things that are, again, at the higher end of the cost of making a piece of furniture, because that all of that specialized tooling, they had to go outside of the shop to have it made, and they weren't going to the local blacksmith to have their screws made. These things were coming from somebody that I'm sure they were importing them from England. They were being made by someone local that was more of like a gunsmith or somebody like that who had more ability, finer abilities with his machine work to create the screws. again, kind of they're going to use them sparingly. You're not going to really see them in backboards. I mean, you might see in an 18th century piece, a 19th century screw holding on some of the backboards. The other thing you'll notice is these things are fairly blunt on the ends, whereas the modern screw is extremely pointy. And I think that has more to do with the fact that we're used to setting up drill drivers and just driving things in automatically, whereas John says the ones with the barrel nuts are better. Yeah. So, I mean, these things are, I think today we're just used to driving them in, where in the 18th and 19th century, what you're seeing is an awful lot of pilot holes being drilled, and then these things are driven in clearly by hand. Maybe once you're in later in the 19th century, mid to end of it, you're probably going to see things, more things like bits that go into a brace or something where you can actually drive in your screws. But for the most part, these things are still driven in by hand until we get out of the slotted screw phase, which doesn't really come about until much, much later. So again, use sparingly, mostly for hardware, attaching hinges and things like that. Quite often, if you're using brass hinges, you'll have brass screws, but not always. Sometimes steel screws are the kind of thing that you'll find even in your brass hardware. But if you're getting wrought iron hardware, say you had a pair of butterfly hinges or rat tails or something like that, those things are really going to be attached using rose head nails. So this is fairly common throughout the 18th and 19th century to find hand-wrought nails. Quite often you'll find now this is a modern day nail that I've got there. And this one is made out of sheet, and the body of the nail is sheared off, and then the head is attached, and these are small cast heads. These are clout nails. I think Tremont might sell them. They don't sell them as rose heads because their rose heads are more shaped like what we have on this period example right here. And I'll lay it down so that it's not flying all over the place. Hopefully we've got some light on that, and you can kind of see that essentially it's 3 or 4 facets around there. Like here's a pretty good one there's clear 4 facets. So these things were hand forged. They would take a piece of bar stock, and then they would pound it out rather thin. They are tapered. The primary difference between these things is the parallel side really isn't parallel on these. So if I look at the Tremont nails, the modern nails, you can clearly see that this is kind of tapered. All right. Let me see if I can't boost it up there on something so you can see a little bit more of the shank of this thing. Hopefully that's a little better. All right. So that modern nail has a very specific kind of a taper to it. And you can tell that they're sheared off because they are all exactly the same. They are not hammered out. They have some kind of a die that comes down and cuts those out of a solid. But if I look at the shank of the hand wrought one over here, it clearly, I'm going to get a pointer so that I'm not sticking my big old finger in the way there. Can you date a piece by the type of nail? That's what Joel would like to know. And the answer is, in a lot of instances, yes. There are certain nails that were made. I mean, you can tell. You know, the hard thing is when you see. So there were certain nails that were made at certain times, and other nails that are made much later. Um, so if I'm looking at a period piece and it's got a whole bunch of these wire nails in there, so these are modern, very modern, mass-produced wire nails. If you go to any hardware store in the country, uh, probably anywhere in the world, you can find wire nails. So these are made in big factories. The wire is, extruded out there, and they cut them off and pound over and add a head, and that's pretty much it. They're just mass produced by the millions every day. The hand wrought nail is kind of tapered, and this is the parallel edge. So on the Tremont nail, let me get that one out of there before I get things way too confused. You can see here, this one's got a very distinct taper in this direction. But if I turn that nail 90 degrees, now that shank, that whole body of that nail is perfectly parallel. So when they make these things, they roll them out in sheet and then they slice them up, stamp them up, and then they bang out the heads. This, like I said, started out as a piece of bar stock that they hammered out to a point. And if I rotate it 90 degrees, so, okay, I'm back on the parallel side there. I'm having trouble rolling it over and having it stay. Let me see if I've got another one here that'll illustrate my point a little better. Actually, these are all fairly uniform. You know, they're tapered on both sides. So here's another one, and you can see in this direction it tapers down, and on that direction it tapers down. Got a little crooked there, but you know they aren't hardened nails, so to straighten them out just means throw this onto a steel plate or something, or an anvil or whatever, and just tap it with a hammer and it'll go back. Sometimes they do break, but these are period nails. These are 18th century, and they've been removed. Most of the time in period furniture, what you're going to find is something that is, like an inch and a quarter, inch and a half long being the longest, and they go down from there. What I couldn't find tonight, somewhere I have a box full of 18th century sprigs, and sprigs are headless nails. So they're they're still hand forged, and they taper. They just don't have the big head up at the top there. And they're much finer. These are pretty thin bodied, no matter what, no matter how you slice it. I mean, this short nail is what, 3/4 of an inch long, and this one, the shank of that thing, is easily as big or bigger than the nails that are 50% longer. Come on, you. And what I was looking for with Mike Michelli showing up is these. I'm going to put them down right down here. These are 18th century upholstery tacks. And they're forged the same way. They're just very, very tiny. They're tapered down. They come down to an extreme point, and then they were clipped off of the bar stock, and then the head was pounded out. These heads are flat, as opposed to the rose heads, which have that faceted top to them. And the idea here is this is more like a sprig. So the sprig would be the body of this nail without a head altogether. All right. So there's kind of short, no heads. There's there's usually you're going to find those holding in exposed moldings, mid moldings, crown moldings, those kinds of things. And nails were primarily a clamping system. And the reason that they used them as clamps, I'm going to pull out that 19th century screw there, and we start to look at that again. And it's that the reasoning is the same. If you're going to make a clamp and you want that screw mechanism on there so that you can turn it and put the pressure on the piece, that mechanism takes specialized tooling, specialized training, and costs a whole lot more. So Norm Abram would have had a really hard time working in an 18th century cabinet shop because there were very few clamps. The clamps really were the nails. So you would put your molding on, glue it up, hold it in place. You would have some pilot holes drilled, and then you would drive in a few sprigs, and they would hold the molding in place until the glue dried up and held everything firmly. On occasion, Tim says, on occasion when I use cut nails, I end up splitting the wood with the grain. Should I pre-drill or change the orientation of the nail? And John wants to know how air nailers work. And are sprigs the same as brads? And the answer, Tim, is absolutely. And do you use pin nails significantly to clamp? And the answer to that is yes. That, to me, is the modern day equivalent of the sprig or the finish nail or a brad. So I'm going to throw a stack of those out there. Of course, they're off to the side. So let's see if I can't find it right on that other side so you guys can see those nails. So the way that a pin nailer works is this is just a whole strip full of nails all glued together. And the manufacturer of this stuff, Senco is based in Cincinnati. And when I worked for Pop Wood, the staff went over for a tour. And we went through and watched them making millions of nails every day. And they have machines that go through and perforate all this stuff. And if you look closely at that, you can actually see it all on the screen right now. This is a whole series of nails that are kind of glued together. And the pinner itself has, I'm going to back the camera up a little and put on the screen my pin nailer. So that strip of nails fits into the magazine, and what you'll find up here is a tiny little, and I'd have to take my nailer apart for you to see it. But there's an air piston up in the head. This is pneumatic, obviously. Otherwise, it wouldn't have an air piston. It would be electric. But there's a tiny little driver pin that when you pull the trigger, it fires and that comes down, and it literally is slightly smaller than one nail, and it just drives it right down and through the front, through the tip there and into the wood. So it's all done on speed. The idea is, get that thing to take a good hard swipe at the nail and drive it in before it can bend. It doesn't always work, but for the most part, it's pretty consistent. The thing that I like about the look of, there's multiple things that I like about it. I'm going to try and pop. There we go. I got one nail popped off there, and I'm not sure you'll be able to see it on camera. And it's standing up on edge right now. So I'm going to try and roll it. There we go. So when I roll it down like that, I'm not sure if you guys can tell, but this head is longer in this direction than it is in the height direction here. And that really sort of mimics what's going on even in our tacks here, the upholstery tacks are slightly wider on one side than they are if I turned it 90 degrees. So the shank of this nail is broader parallel to my workbench than it is vertically off of the workbench. So they're not perfectly square, which is kind of that same thing that you get here. You get that kind of rectangular look. And that's very correctly mimics what's going on in period sprigs or brads. Sometimes sprigs are really tiny. I mean, you'll find brads that are, 3/4 of an inch, inch long, 1.25 inches long, something like that. Sometimes to hold moldings on, if they're a little thicker, they're pilot holing, those things too. So somebody asked about when they're driving nails in, they're splitting the end. So that's one of the things that I wanted to talk about with, you can see the period rose heads come down to a very sharp point. I mean, almost consistently. And what I was taught when I went through vocational school for woodworking, carpentry and cabinet making specifically, is that pointed nails tend to split things, because when they go in, that sharp point starts to separate the fibers. And what we know about wood is that those fibers are very strong over the length. So if I were to drive it into my workbench top this way, if it's pointed, it's like splitting it for firewood. I'm driving it in and I'm actually separating those fibers. And those long fibers are running this way in the workbench top, and they want to stay together. It's very hard to snap them off. So by driving that point in there directly, it's going to start to separate those fibers, and they're going to stay intact, which is what's going to cause that overall split in there. So what we were taught to do is, if we were using wire nails, is stand them up on end and hit the tip with the hammer and blunt the end, which is exactly what's happening on the Tremont, the modern day version of the rose head. They have a very blunt end. And what happens when you have that blunt end on that nail is it doesn't separate and continue to push the fibers apart. It actually tears through them, sort of intertwining the fibers as it rips its way down through that group of fibers. And it actually ends up locking itself in a whole lot harder than a pointed nail. The ends of the pins that are in the pin nailers are kind of blunt. They have a very slight chisel point to them, only in one direction. But they're fairly blunt, and they're covered with glue because that's how they keep them all together. And when you drive them in, it heats up that glue, and that also sort of makes them very, very difficult to pull out there. Where, like period rose heads, I don't know if you guys, I mean, Troy had mentioned the article in Fine Woodworking. This is sort of what inspired this months ago when I knew that this was coming out. The article was coming out relatively. It's only been a few weeks or so since that issue hit the street here, I think. One of the things that I do to my Tremont nails, and if I'm using period nails, which I've got hundreds of thousands of these things. So if anybody's looking for period rosehead nails, contact me through the website and we'll work out a deal. But what I do with the Tremonts, because even though these have blunt ends on there and it's pushing those fibers over and ripping them, making it more difficult because the fibers then brace themselves against that nail. These nails are really smooth, and quite often they'll just pop right back out. So what I do with the modern Tremont nails is I soak them in muriatic acid for, well, I said in the article, at least overnight. Sometimes I'll throw a bunch in the muriatic acid for a couple of weeks. And then when you pull them out of there, it's pretty diluted. It's the same stuff you use to clean a swimming pool. So it's a light acid. Um, you know, what it does is it etches through some of the galvanizing that's on this stuff. And then you can see on these period ones, they have just a light coating of rust. And the cool thing is, once you get that light coating of rust on it, you take them out, you wash them off, you let them sit there. The fact that you've soaked them in an acid with water and then you did the acid by washing the nails off adds more water to the mix, and whatever is in there starts to corrode a whole lot more when it's exposed to the air. And now what you get is this nail with a blunt end tapered in one direction only, and we're going to talk about that here shortly. I do have a board and I forgot my hammer. Live woodworking, folks, not edited for your viewing pleasure. So this one's tapered in this direction and parallel in the perpendicular direction. So what that means is I need to make sure that I orient this correctly so that I am not putting the wedge going perpendicular to my grain in my board, the fiber direction. So if my fiber direction lines up this way, I want that wedge perpendicular to it. I don't want the wedge perpendicular to it. I want the wedge side of that nail running with the grain, because that way it's not separating those fibers. Whew, live woodworking again. Okay. The problem you've got is the period nails, the period rose heads, like I said, are tapered on two sides. And that's almost every period rose head nail I've ever gotten is tapered that way, because the blacksmith was just hammering them out. And the good blacksmith could hammer out 200 or 300 an hour. So they were banging their way through these things, cutting them off, dropping them in the anvil, and then hammering over the rose head on there and then off onto the next. Probably faster than I just described how they made it. So even on the rose, even if I'm using period rose heads, I'll wash them down a little bit with a muriatic acid and then let them sit and rust up a little bit, so that once you drive them in, they have a little bit more grab because of all of that extra texture on the surface. Let me check those questions real quick. Okay, do you use pin nails significantly to clamp? Yes, I answered that one. Is Senko or Grex worth the higher prices? I believe so. I had Senko guns for the longest time, and now I've almost completely switched over to Grex. I still have some of my oldest Senko guns. I'm going to switch cameras because you guys are, staring at nails, not moving. All right. So if I look, so this is my oldest gun. I got this back in the, I'm thinking mid to late 80s. It's a Senko. It's all some kind of a magnesium or metal composite kind of body on this thing. And I had a couple of these, and I've gone, this is, like I said, this one's my oldest one, and it still works just fine. It's an 18 gauge pin nail, just like this one. Are they worth it? Yeah, I think they are. If you're looking for something that's going to last a long time and have fewer jams, easier to fix if something does jam, this one Very rarely jams in the entire time I've owned it, maybe half a dozen times. But nobody makes guns like this anymore. The Grex guns, what I like is everything's removable. So I can start to pull everything. If something jams, I can pretty much disassemble the whole lower carriage of this thing, other than the air. Well, I can pull the nuts off of this and disassemble the whole head too. But I can, if something's jammed in there, if it misfires and drives 2 nails instead of 1, which again doesn't happen very often, I can disassemble absolutely everything, clear the jam, and then reassemble it and get right back to work. And it's pretty easy to do. That's what I think the whole thing is here. Oh, Patrick's here. Awesome. Brian says his Grex works great, and I think the quality of the gun is worth the extra dollars. That's exactly what I would say. I mean, you can buy much, much cheaper pin guns. But the idea is you're going to get what you pay for. I can tell you Senko's newest guns don't have that same quality of that really early gun, but they're fairly close to what's going on with Grex. I think I have one. I'm trying to remember what the brand name is of my. I have a Porter cable. You can see it gets used a lot. It's in a heavily dust covered. This is a 23 gauge pin nailer. And I just never really liked the way, I mean, I had more trouble with it not functioning the way that I liked than I've ever had with the Grex stuff. The Grex just, I have the 23 gauge pinner for that. It's a lighter weight gun than the Porter cable a little bit. I like the grip a whole lot better, and I can get into places. Again, I can disassemble things a lot better than I can on the Porter cable. So the Porter cable's nowhere near the price of the Grex, but it's also more problematic when we get there. What do you do when a pin nail doesn't set enough? So if the pin nail does not set enough, and I should have brought one of these over. I was not expecting this to turn into a discussion of pin nailers, because I didn't even have that on the table when we started. I'm going to switch that camera back, and I'm going to walk off camera here a second and go grab what I use. If I can find it quickly. I don't want to waste a whole lot of time here, but you can keep looking at those wonderful 18th century nails. Here we go. It's not my favorite one, but there's, I don't know where somewhere I have a Starrett nail set that I ground. This is not the Starrett, clearly. This was like the cheapest thing I could find at Home Depot. And what I did was I ground the end. You can see I've ground a flat on 4 sides, and I bring it down to a fairly tiny, it's not a point, but it is a flat. And if I put it right up against that, you can see it's about the point of the nail set is square, and it's about the size of the head of an 18 gauge pin nail from the pinner. And the whole deal there is I'm not driving it with a round nail set. I'm driving it with a square nail set, so it still leaves a tiny little square hole. And since I do period furniture, and I want my stuff to pretty much mimic what was being done in the period, I want square holes. I don't want round holes, because if they're round holes, then everybody thinks I used wire nails. Now, should you care about that? That's entirely up to you. That's all personal preference. It really doesn't make any difference to the way it holds. You will find that trying to set these, I would say at this point, probably 20 or 30% of the ones I set, you'll tap the nail and the nail set will glance off and just make the hole wider with the nail not fully set. So then you're going to have to go back and reset the nail again, which then means you have a slightly bigger hole. So why the Grex? What's substantially better? What's substantially better is that the firing mechanism is smoother, longer lasting. I get far fewer misfires. I get it usually sets the nails pretty regularly. The only way that it doesn't set the nail down below the surface is if I've done something stupid like angle the gun or pull up as I'm firing because I'm just going too fast. Yeah, everything about it's better. You also get better seals. It's a better air piston in there. It's just a much longer lasting piece of equipment. Now, all of that said, and I'm going to switch back to the wide camera because I'm getting bored looking at that. So you got to be getting bored looking at that too. All of that said, if you're working in your shop 1 or 2 days a week, you might only use a pin nailer once every couple of months. It may not in the end be something that is worth your time and money to go buy a much more expensive gun when you're never going to put it through its paces to really make sure you get the longevity out of it. It's not like it's going to go bad sitting there. There's nothing wrong with owning a really good tool. It'll work every single time you do it. You grab it and go to use it. The big thing is some of the really cheap guns, like if you went to there's a company out there that they sell everything under the sun. It's all made very inexpensively, and they have stores everywhere. And you could go in there and you could buy an 18 gauge pinner for 1/3, 1/2 the price of a Grex, maybe even 20% the price of a Grex. The difference is if you're going to use it an awful lot, it's probably going to break down more, and it's going to jam a little more, and it's going to be more difficult to clear the jams once you do. So those are the things that I see that are good about the better guns. What if the compressor pressure, try and say that 5 times fast. What if the compressor pressure is the problem? Yeah, well, that could be a problem if you don't have a compressor that gets up to a high enough pressure or doesn't put out enough cubic feet per minute of compressed air. If you're using I don't have a pancake, but I've got what I have left in the shop at this point. I used to have a 80-gallon 2-stage compressor for the shop because we used to run pneumatic sanders, random orbit sanders. That I've switched over to the electrics, I have a Festool and a Merca. I don't need to run the Dynabraids anymore, which were all the air-driven palm sanders. Super nice, but they suck down air like mad. So I had to have a big compressor, which meant when I used my pin nailers and things like that, I always had more air pressure than I ever needed. So what I've got is a Senko that's just basically 2 tanks. It's about a 4-gallon, and it's about a 1.5, maybe a 2 horsepower motor on that thing, and it puts out plenty of air. I don't think I could fire enough to to make it so that it wouldn't have enough air pressure. Now, if you're using one of those tiny little, really quiet Senko versions that are, I think it's the N1000 or something, it's maybe a foot long, and you can carry it, weighs about 5.5 pounds, and you can carry it around. I think if you're trying to speed nail something, you're probably going to run out of air before you're going to start firing, and that thing, the nails are going to be sticking up a half an inch out of the surface. Douglas says he has an antique hutch with round head slotted screws driven into the stiles of the case and into the case sides and visible on the surface. Does that date the piece? Your best bet would be to send me pictures of the piece overall, and then some detail shots, including shots of the screws. And I can try and, it's possible that it dates the piece, but it's also possible that something may have started to come loose, and at some point in its history, somebody added screws to make sure that it wasn't going to fall apart. So it's hard to tell just from a description like that. John says he uses only 23 gauge or smaller, correct? Well, this was an 18 gauge that I had here. I also have a 21 gauge and a 23 gauge. 23 is the smallest I've got. They leave the tiniest holes, almost no filling required. Usually, if I'm pinning on a molding with the 23 gauge, what you'll find is you lightly sand it, and then when you put your finish on, between the sanding dust and the finish getting into those holes, they almost completely fill themselves in. Very little filling is required, much more so required on the 18 gauge pins. The thing that I don't like about the 23 gauge pins is that they're so thin that once you start, you can actually juggle a molding around while the glue is still liquid. You can slide it around, which in some instances that's helpful. When it's not helpful is when you think you have everything set and then you bump the molding and now it's all discombobulated. So that's why I also went to the 21 gauge, because to me that's the hybrid between the 23 gauge, which is the smallest that I've seen you can get, and the 18 gauge, which was the industry standard for 20 years before they started making them smaller. So that 21 gauge is right in between. You get a really tiny hole, but that nail is significantly thicker, so you get a stiffer hold, if that makes any kind of sense. Boy, this really went off the rails of where I was going. Brian says you use a 1.5 horsepower California Air, works fine. Right. You're never going to, depending on how big the tanks are there, Brian, chances are you're never going to run out of air. You're never going to have a low air pressure kind of a thing. John, when I brad nail trim, I take note of the tip direction with 18 gauge nails to minimize the splitting, especially toward the end. Correct. You have only boss stitch or Porter cable. Yeah, boss stitch is pretty good too. The Porter cable stuff is a little iffy to me. I mean, it works, but I've always sort of felt like since Porter cable stopped manufacturing everything here, and to some extent that's kind of what's happened to Senko. That Senko gun that I showed you a few minutes ago was made, the one from the 80s was made here, but they've put everything out there. So at that point, things tend not to be made the same way. So I think that's a lot of that happens with the Porter Cable stuff, more so than like with the better names, Bostitch or Grex. Those things, those guys, Grex is not made here, but they're they're based here, and I believe Bostitch is too. And there's just a lot more quality control trying to get their stuff made. Senko Troy says Senko used to be the best, but no longer. What sizes do you use the most? I think I covered that. How does 90 psi sink a nail? It probably ought to sink it fairly well. What is the Grex pin length range? I think I have 1.5 to 2 or 2.25, somewhere in there for some of my guns. In most sizes, the 18 and the 21. Now my 21 gauge pin nailer says it'll take 3/8 on up to 1 3/8. But the 18 gauge, let me grab that, says it'll do 1/2 inch to 2 inch. I think some of my Senko guns might still be a little longer. They're more modern Senko nail guns. So if I really have to drive like a 2.25 inch nail, why I would have to drive a 2 inch, a 2.25 versus a 2. I can't think of any reason off the top of my head. Kevin says he loves his Porter Cable. I've never had a bit of trouble with it. That's perfect. That's good. Find something you like and work with it. That's all. Okay. Thanks for 20 bucks. Yeah. That's what at the harbor store. Yeah, that's what I was talking about earlier. I'm not really sure those are. I mean, I've had some of their pneumatic tools in the past. They kind of hang in there for a while, but they're not made to last 20, 25 years. But then again, few things are today. All right, I'm going to switch back. I want to talk real quick about square pegs and round holes. I actually use one of my square pegs. Let's slide all of this nonsense out of the way. So I've got a couple of period pegs here that were driven into pieces, and then and you can tell because the tips on these are kind of crooked. So they went through, and as things changed, I was trying to find, there's another one that I had that started out nice and square, and it's sort of like double teardrop shaped. It came to real sharp edges, and the two sides were rounded over. So when you really think about the hole that it's going in, 50% of the hole is end grain, and the other 50% is side grain. So the sharp edges stayed sharp going through the side grain, and really just wore off going through the side grain. You can see the tips are kind of faceted here on both of these. They were whittled down with a knife or a chisel. And then I made a pair of starter pegs here in the shop so that we could take a look at it. I'm going to shift the direction of the camera here shortly, and I'll show you how I point them up. Let's get rid of all this nonsense. So the primary differences, this was the stuff I made for tonight was stock that was sawn. This stuff was riven, and what they looked for was very straight grain material to split their pegs out of, because that way the pegs don't have natural crooks to them. They're nice and straight. I know at some point somebody's going to want to know, did they make all their pegs out of quarter sawn white oak or something like that? And the answer is no, they didn't, because sawn is sawn. They didn't rive them from a specific type of wood. Through most of the 18th century, the pegs are or pins are the same material as the primary material of the piece. So if you're building a chair and you're going to peg the mortise and tenon joints and you've made the chair out of mahogany, your pins are mahogany. If you've done it out of walnut, your pins are out of walnut. They weren't really doing the contrasting color thing at all. And I've never really seen anything that I've had in for restoration work where the pegs were, I never saw a piece that was made out of mahogany with oak pegs or walnut with cherry pegs or anything like that. They started with square stock the same way that I am. Again, what I did was I picked really nice straight grained quarter sawn material so that I'm getting the least amount of angular motion out of my fibers when they stack up. So pretty much when I look at these on both edges, the fibers are in a nice straight line parallel to the sides of my my pegs. If the grain were running at an angle coming across here, I'm creating a short grain situation here. When I start to drive that peg in, there's every likelihood that I could just shear the peg right off rather than drive it in. Again, these fibers, that's why they rive their pegs, because that keeps the maximum number of fibers lined up end to end. When we saw, there's no guarantee that these fibers are lined up end to end all the way through there, because as we slice through, we're not necessarily having our plank oriented in the tree so that the fibers are dead straight to the edge of the plank. So this one actually has a slight angle. So these fibers start right here and they come across, what's that, about 20, 30 degrees, maybe 10 degrees, 15 degrees. But it's a very slight angle coming across there. So they enter here and go out there probably over, this is 1/4 of an inch wide and it's probably 1.5 inches long. This piece the grain is on both sides, very much oriented straight through. So at some point when I sawed this stuff out, the grain took a slight curve relative to the edges of my plank. Skip wants to know the best manufacturer for pin nails. Well, I can tell you, having gone to the Senco plant and seen how they make them here in the US, I don't think you can do a whole lot better than that. That said, almost all of my pins are from Grex at this point, just because. John wants to know, when I drill a pilot hole for a screw, do I use the miner? Here we go. Now I'm going to move my camera a little bit and then back it up a touch so you can see what I'm going to do here, because I'm going to mess around with these pegs. And during that time, I'm going to try and answer that question. So he wants to know if when I'm drilling my pilot hole for a screw, am I using the miner diameter, which is that at the bottom of the well on the threads, not this shank diameter or the outermost part of the thread itself as I roll the screws all over the place? Yes. So I tend to, now that becomes more problematic on those really on those 18th century ones where the threads are demonstrably deeper than they are on the modern screws. So I tend to go slightly larger in diameter than the minor diameter of my piece. And that's just so that I don't split things. But generally speaking, I use that minor diameter for that. Kevin wants to know, how are the pegs sized? In other words, you want to know how I make them? For the most part, this peg here, which is probably the better of the ones that I've got, it's pretty long, and that's about 3/16 square. Most of the pegs that I've made and put into pieces tend to be closer to 1/4 inch. I slice mine on the table saw. I've got I have a video on YouTube. If you look on how to make stringing, it's not a whole lot different to make it 1/4 inch rather than a 32nd or a millimeter or whatever. Dexter wants to know, are those the same as drawbore pins used for mortise and tenons? Yes. And John says it makes sense to rive the material. And yes, it makes even more sense if you're draw boring. So when I draw bore, what I'm doing is I'm drilling a hole through my tenon or through my mortise. And then I insert my tenon, mark the center of that hole. And then what I'm doing is I'm offsetting those two holes, and I'm offsetting them towards the shoulder of the tenon, so that when I drive the peg through both through the stile, which has the mortise in it, and the rail, which has the tenon in there, it's actually pulling those two holes closer together and in line, which this clearly was not a drawbore peg, or it would have a natural curve to it when it came out of the piece. That's what I was looking for. Somewhere I have another small box of ones that I've driven out of chairs and things, where either things have shrunk up over time, or they were drawboard to begin with. And the pegs started out nice and straight like this one did, but once they go through the drawbore and they've sat in there for a couple of 100 years, some of them have very clear dog legs to them. Some of them have a nice continuous arc to them, which is kind of cool. Again, stuff for other shows. I'll try and find that kind of stuff so I can show you guys that stuff. With taper screws, you need to use a taper bit and careful judgment. Yeah, kind of. Drawbores, I like to taper the pin tips before insertion. Yep. And that's really what I wanted to show you here. Is, for the most part, I'm going to use the one that actually has the nice straight grain lined up there rather than the one that's off on the angle. And the only thing I do is I hook it and for the most part, I'm not trying to get an absolutely perfect round on this thing. I'm really just kind of chamfering the ends a little bit. Again, if we look at period pegs, there's nothing uniform about that. This angle is, that's angled. This one's straight. It's only chamfered on 3 sides on that piece. And they used to let the pegs stick out in there. This one got that same kind of thing going on. That's actually chamfered on 2 sides, and that's it. I'm not much for the 2-sided chamfer. I knock the corners off. If I'm doing a ton of these things, I have a hand crank pencil sharpener in the shop. Stick the end in the pencil sharpener. Let's see, what else? Oh, yeah, the other thing, so the big thing was years ago, drawbore pins were a big thing, 2 metal pins that when you drill your mortises and your tenons and the holes are offset there. You then drive that drawbore pin in there, it's a tapered metal piece, and you try and pull your mortise and tenon together before you drive in the peg. And all that really does, or at least all that I've ever really seen it do for the people that have done it, is it sort of elongates the hole in the tenon that you very carefully offset, and this doesn't do the job the way that it should. So once I tip that up, the way that I have it, and I'm going to try and wrap this up pretty quickly here because we are over an hour already. So I've got a piece of walnut. This is a 1/4-inch pin, and what I do is I go about a 64 small on the hole. It's just something that I've done. If I know I'm going into highly figured stuff, I might go a 64th larger. But generally speaking, I try and make it just slightly smaller than the try not to drill through and into my bench. Drill the hole. Probably should have had something backing that up under there, but whatever. Hey, and I really do need that hammer now. So I'm going to walk over here and see if I left it on. Yes, I left it right on the other bench. So the only other thing that I do, so I've drilled this purposefully close to the end of this board so that you guys can see what happens when I drive that in there. Hopefully I don't split this. That's the whole goal here. I've only tipped up the end. I don't usually knock off these corners farther back on the peg. One thing that I do, I have some beeswax, and I will rub a little beeswax the entire length of my peg. Now this peg is way too long. If I was actually pegging something in a board that was only 3/4 of an inch thick, I'm not putting a 2 or 2.5 inch long peg into that. So, really, I'm going to sort of set this in place. And hammer down and bring it out on the inside there. Usually what you'll find is pegs stick through the mortise on the inside of a piece. They usually stick out 3/8 of an inch to a 1/2 inch ballpark. This would then be cut off and sort of sanded down. The period pieces, this tends to be slightly raised, which I don't think was an original. I don't think the original intent was to leave it above the surface. I think just shrinkage, expansion, and contraction over the years. So you can see by drilling that pretty close to that 1/4 inch size, I'm only 3/4 of an inch off the end of that piece of walnut, and no cracking going on there. So if you're finding you're having a whole lot of trouble with that, then start to push the diameter of the hole up. So instead of a 64th under, maybe go to the 64th over, test it. This is a test piece, not a finished piece. And I would test that with a, to make sure that my hole isn't too tight on my pin. The other thing you'll see is where this came through, and I'm going to try and get it zoomed in there. If I could just keep my remote in my hand, it would be a lot easier. What you'll see is where it came through here. This is now really round all the way back here. And you when I tipped that up with the chisel, I didn't go that far back. And it was not round. It was still square. It was just faceted. And now if I look at it straight on, you can see it's clearly round because the end grain, 50% end grain on this hole, really just sort of burnished that pin right over. If I cut that off, which I can probably do fairly quickly here. Yes, yes, yes. Don't saw towards your hand. I'm a highly trained professional, so don't do this at home. And what you'll see is that peg is still kind of squarish looking in the hole. If I were to drive it back out just a touch, you can probably see that it's still square. Okay, so that's the whole deal there. This stuff really, they're meant to look square from the outside. The square stops them from rotating. And that was something that somebody asked earlier when they start driving the tapered nails. Okay, so let's talk about that real quick. Okay, modern nail tapered on this side, parallel on that side, grain running this way in this board. I have the tapered side facing the camera. The parallel side is parallel to the edge of my piece. I would drill a pilot hole. Pilot hole that I'm going to drill is usually right around, so this is the parallel edge of that nail, and it's usually right around that same thickness. So it's using the same terminology that we did for the screw, it's going to be the minor diameter. Okay, so what I normally do is I just take something, the tips on these modern rose heads are pretty square, so I just usually find a drill bit that's approximately the same size as that. Do you leave all show side pegs square? If so, no need for a Lie-Nielsen plate. That is correct, Troy. I don't. I leave them square out here. If you look at 18th century stuff, again, it's all personal choice. If you don't like the square look, don't make your pegs square. I'm not here to convince you that my way is the only way. I mean, it is, but I'm not here to convince you that. And that was a joke, mostly. But the idea is, if you don't like the look of the square peg, don't do it. If you like them round, make them round. What do I care? And why should you care what my opinion is on it? I know there was other stuff that I wanted to cover, but we diverged in a couple of different directions here. Yeah, you can see I'm sitting down. It's 9:15. I'm done for the day. The key thing that I really wanted you guys to walk away with from here is, seeing how some of those old pieces look, how they're made. We talked a little bit about how they were made, why they maybe made them that way. I'm sure at some point here I have something planned for, tacking moldings on and things like that. So I saw somebody had mentioned, a couple of questions. Right. Somebody said, I can't remember whether it was, the question was for pegs or for nails, but they were having trouble. It was early on in the chat there. Oh yeah, what's going on? That was the one. Oh, Jeffrey's here. Awesome. I missed that. Sorry. Okay, periodically when advancing square nails, they will rotate to the point that I need to hold the head with needle nose to avoid. Okay, what's going on there? So if you're just driving that nail straight in, I almost always drill some kind of a pilot hole for these things, and that really sort of stops that corkscrewing going on. I think a lot of why that happens is grain direction. You're ripping down through those fibers. Those fibers might be coming in at an angle, and everything starts to twist and rotate around. If you drill a tiny little pilot hole for this, I've never had a problem with them rotating, so that usually solves that kind of a problem. At least I believe so. Again, just thinking about how that rips through those fibers and presses them all down so that you can't draw the nail back out. And the fact that, like on this flat sawn piece of walnut, that grain direction is running at some kind of it's pitching up towards this surface from that. It's on an angle and it's running off to that side. So everything is running from like this corner up to this corner on this piece. So if I just drive the nail in, those fibers are coming at it in a three-dimensional sense from two directions. And now it's gonna play off of those square surfaces and start to twist things. I'm going to drill a pilot hole for my screws. I'm going to drill a pilot hole for my nails for the most part. Again, one of the best things you can do for the modern Tremont, and I keep saying Tremont Nail Company because I don't know of anybody else that's making these things. There was a blacksmith years ago who came through the furniture shows that I was doing, and he was buying Tremont nails and then heating them up and peening them and turning them into more accurate representations of the period rose heads. But he was using Tremont nails to do it. So, that's, and then he was charging $3 or $4 a nail. So, which, honestly, that's years ago. I remember for 1.5 to 2 inch rose heads, for period ones, some of the guys I know were charging $5 a nail. Joel said again, that's the earlier question. Yeah. Sorry. Yeah, Kevin said, okay, they weren't Tremonts, but they were another maker. Yeah, I always pilot. Did you pilot them and they're still turning? If they are, were they hand wrought? Because that might indicate that the nail wasn't centered, wasn't essentially straight. If I go back to, and I really messed up my pile here, and I don't. Well, I can still see it on the camera. So if I take those period rose heads, and I'll throw the other camera on real quick. And then we'll wrap this thing up. But, these are fairly balanced. They got a little, like this one's got a little crook to it. So like I said, if I was going to fix that, I would probably do it on top of a metal plate. But even on my workbench, I can kind of straighten that crook out of there a little bit because these are still malleable. They weren't hardened. They were just hammered out on they heated the iron, hammered them out on an anvil, threw them in a pot, threw them in a bucket full of nails. But they're fairly tapered in both directions, but they're balanced. So what I'm trying to figure out, okay, so you didn't always pilot them, Kevin, but it was another maker. So I would always pilot them if it was me, because I do that with the Tremonts. One of the blacksmiths that I've used over the years for buying rat tail hinges and butterflies and things like that. When he would forge the hinges themselves, he would make a bunch of nails to go with it. And even those, I drilled a pilot hole because, when you're putting 4 nails into one leaf of a butterfly hinge, they, unless your butterflies are huge, those nails are fairly close together. And I mean, if I were to take another wooden peg and move it over an inch from where I just drove the one into this board, now I've got twice the chance that I'm going to crack that board right in between those two, the two pegs, or straight out the end of the piece. So if I'm putting in a hinge and I've got rosehead nails that I'm driving in, if I don't drill the pilot hole to give it some kind of relief on a butterfly hinge, if those two nails are an inch apart, chances are you have twice the chance of cracking your piece. So that's about it. Hey, we've gone an hour and 25 minutes tonight, which is. And Frank says Peter Ross will make nails. I'm sure Peter would. I don't know what he would charge for them. Most of the blacksmiths I know, if they're, like I said, if they're making me rat tail hinges or butterfly hinges, something like that, where they're forging the hinge, they make the nails. If I buy cast iron hinges, I get them from Ball and Ball, and they usually come with steel screws, more modern ones. I mean, they have several screw machines at Ball and Ball, which is something we ought to do at some point, because those guys are, I had to take a ride down there, and we ought to do for one of these, I had to just go down someday and film a little bit, and then for a Tuesday night we can all sit around and watch the visit to Ball and Ball, because they're the last of the hardware companies that are still in family hands here in this country, that were making stuff the old way. So it'd be a shame to not document a little of that for posterity's sake there. So I think I'm going to call it an evening. Like I said, we're closing in on 9:30, so we're almost an hour, closing in on the hour and a half at this point. So, which is way longer than I really wanted to do this. But you guys had a lot of really great questions. If I missed something, if I didn't answer a question, or if you come up with other questions, please drop them down into the notes on the YouTube channel, down into the comments section, and I will try and answer them. Thank you guys for coming out. If you liked the video and you've made it this far, man, you're better than most people. So please hit that like button, hit the subscribe, and ring the bell if you're on YouTube to get the notifications, because you really don't want to miss any of this. I'm going to do this again next Tuesday night. And, I looked it up, but I cannot remember what I was going to do next Tuesday. If you haven't signed up already, go to the website, sign up for the email newsletter, and at some point you'll get a reminder email, which will have the topic for next week. It seems to happen reasonably regularly around here that I don't remember what I had scheduled. So thank you guys for coming. I really had a lot of fun tonight, and I appreciate you guys sticking it out to the end. See you next week. Good night.